Now let's move on to discussing how to use difference in differences methods. So why would you want to use a difference in differences approach? This method takes advantage of two types of variation and exposure to the policy or intervention of interest. Variation in time, before and after implementation of the policy or intervention, and variation in exposure to different groups that are exposed to the treatment or not. So for example, states that did not adopt a policy or clinics that did not implement an intervention. And this method works well for when there are sharp points of change in policy or intervention, and when there is data on a comparison group that did not receive the treatment of interest. So in theory, we could just look at a single difference in change in outcome. So for example, we could look within one state at the effect of policy on mental health service use by comparing service use before and after policy implementation. Or we could look at a state that has a policy and compare mental health service use in that state to service use in a state that doesn't have this policy. However, these single differences ignore important confounders of the true policy effect. The first difference, just looking at pre and post, confounds the policy effect with changes over time. So is the change really due to the policy or intervention, or is it due to an underlying temporal trend? The second difference, just looking at treatment and control, confounds the policy effect with differences in the states or clinics or whatever unit of analysis you're looking at. There could be important differences in these states or clinics beyond just the policy that influences your outcomes. Instead, what difference in differences allows us to do is to use the comparison group to estimate what the change over time would have been without the change in intervention or policy. This assumes that changes in outcomes over time are unaffected by unobserved variables and is equivalent to fitting a regression model of the outcome with indicators for site, so treatment or control, and time period, post versus pre, and the interaction between site and time. The outcome of interest, so the estimated effect of the policy or intervention, is here the beta 3 interaction term. These are some made-up numbers for an illustrative example. So let's say that we are interested in looking at the change in the average number of outpatient mental health services used per person per year in a given state that has implemented a policy that we expect would affect this outcome. So we've collected some data here in the treatment state and in a control state that did not have a policy change. And we have data from a time point before the policy was implemented and a time point from after the policy implementation. If we look at just the pre and post in the treatment state, it looks like we've increased service use by an average of 5.5 more services per person per year. However, if we look at just the post-period differences between the treated state and the control state, it looks like we've increased service use by only 2.5 more services per person per year. To estimate the true effect, however, we need to take the difference of those differences. So 5.5 minus 4.2 and 2.5 minus 1.2 both give us an effect of an increase of 1.3 services per person per year. When we think about difference in differences in a regression context, these are the common notations that are used. So we have our y of t, which is our observed outcome at time t. We have an indicator variable for treatment or control. And we also have a time indicator for pre-intervention time points. For now, we're looking at just one time point, and post-intervention time points. And there could be a potential outcome under either treatment condition at any given time. In the regression model, we can also observe for covariates, so we can have x's, and then we also need to remember that there are unobserved covariates that we will not be able to control for. What are we estimating in this regression? Usually we are estimating the difference in outcomes in the treatment group compared to what we would have seen in the treatment group had the intervention or policy not been implemented. And this is the average effect of the treatment on the treated, or the ATT. Let's talk about the key assumptions underlying difference in differences. The main assumption is the parallel trends assumption, and here we're assuming that without the treatment, the groups would have had the same trends in the post period. In the regression model, another way of saying this is that without the intervention, the interaction term would be 0. This assumption really focuses on the post-period counterfactual and so is not testable. You might say that if the pre-period trends are similar, you have greater confidence that the post-period trends would be similar, but we cannot know for sure. Another important piece of this is that there is no concurrent change happening in the treatment group at the same time as the policy or intervention of interest. Otherwise, we would not be able to disentangle the effects of the two policies, this policy of interest and the other change. And then, as with any regression model, the difference in differences approach relies on a linear model, though non-parametric estimation is possible. There are a few extensions beyond the difference in differences model we have been discussing, with just 2 groups and 2 time points. And these are interrupted time series models where you have outcomes over time. The first interrupted time series model has just a treatment group and models outcomes in the pre-period and projects that out into the post-period to look at the difference between what would have been observed and what was observed. A comparative interrupted time series includes a treatment and a control group and is able to model trends over time, so it adds more time points to the difference in differences we have been discussing. I also wanted to highlight that there is work being done on better estimating effects when policies or interventions are adopted by different places at different times. Recent work has shown that standard difference in differences approaches can be biased basically because the pre- and post-periods are not clearly defined, and some parameters are estimated across the whole time period. Instead, more recent approaches basically do a series of comparative interrupted time series models and stack them on top of each other. And there are references listed here for some different approaches for the stacked CITS. Finally, I want to end this section with just a few notes on considerations for when you are conducting a difference in differences analysis, or causal inference in general. First, this method works best when there is a sharp change in policy or intervention with clear-cut pre- and post-time periods. Second, it is important to understand the underlying mechanisms of the policy or intervention and when and why we might expect to see effects. Ideally, outcomes are reliably measured across time and sites and are stable in the pre-period, and this would give us more confidence that the effect we're looking at is not just a blip or kind of within the range of what has been measured before. Related to understanding the underlying mechanism, you want to have a compelling story for what you're expecting and why the assumptions hold and how this effect works. To help build this story, it's important to do sensitivity and other analyses, such as looking at subgroups, to see if and when effects are seen and if they are robust to changes in specifications. Finally, you want to test assumptions as much as possible to increase confidence and validity of causal claims.